In this particular chapter, the book does describe the division rule. I have an example for you. Maybe there might be another example in the book, but that's about it. They're really actually setting you up for another topic that we may or may not get to in this class. So it's going to be brief, short, and to the point here when we get to, frankly, this example here. But what we're trying to do is we're trying to figure out that there's going to be a bunch of different options, but we have to divide it in order to complete a task that we were asked to do. And that procedure is carried out in N ways, but there's D corresponding outcomes. So that's your divisor that you're going to need for all of this. In terms of functions, these are two items that you can use, terms of sets, and then terms of functions. Honestly, these are two items that you're welcome to read over, but I don't go over them too much because of that chapter that's coming up that we can go over. So let me get to an example here more than anything else here. So how many ways are there to seat 4 people around a circular table? You're going to see graphs and pictures here in a minute, where 2, and that's where the D comes into place, seatings are considered the same when each person has the same left and right neighbor. There are 4 ways to select the person for seat 1, which I'll show you here in a second. Again, pictures of 1,000 words here. And when we first start our labeling here, you're going to see A through D, and then there's going to be 4 options where each of them shift. What does that look like? And by the way, just keep it on to 4 times 3 options times 2 options here. So what's this going to look like? So the original setup is going to be our 4 items that we have here. Now all I'm going to do is shift so that A stays basically beside D, A stays beside B, and then C by default is by itself. So you're going to see me shift, actually the other way to be honest with you. So notice A is still beside D and A is still beside B. I can do that one more time and then one more time. So there's going to be 4 different ways with all the possible combinations here, 4 factorial. It's 24 ways to order the 4 people. I could just swap things just as long as they're beside each other, which is our N. But here's where the division comes into play. But since 2 seatings are the same with each person, the same left and right neighbors, for every choice seat of A, we have the same seating 4 times or 4 shifts, which is D. Therefore, by the division rule, which is our N, which is our 24, and then our 4 different shifts that we have, there's going to be 24 divided by 4 equals 6 different seating arrangements. Like I said, this one we get into in other chapters later on where it gets a little bit more complicated, but that's where we're going for right now, keeping it simple and short and sweet.